For years, the world of artificial intelligence operated on a simple, almost sacred promise. It was a promise so powerful it felt like a law of physics, a predictable engine driving the future. This was the scaling law, a straightforward recipe for progress. The formula was clear: feed the models more data, build them with more parameters, and throw ever-increasing amounts of compute power at them. And in return, the models would simply get better. Not just incrementally, but with emergent abilities that felt like magic. This predictable march of progress created a gold rush. That story fueled tens of billions in bets across the entire AI ecosystem. Venture capitalists, corporations, entire nations, everyone wanted a piece of the exponential curve. The titans of the industry, OpenAI, Google, and Anthropic, all went all in on scale, building colossal models that consumed city-scale power. And the companies providing the shovels for this gold rush, chipmakers like NVIDIA, saw their valuations soar into the trillions, riding the unstoppable wave of demand for more compute. But a new paper just hit the brakes on that entire narrative. It didn't test for simple pattern matching or text completion. Instead, it tested a core, uniquely human skill: analogical reasoning. The ability to understand relationships and map them from one domain to another. The results were a shock to the system. It wasn't the largest, most expensive models that performed the best. The shock: medium-sized models did best. Bigger sometimes got significantly worse, their performance collapsing on these nuanced tasks. The implication is profound. The era of easy gains from pure brute force scale may be ending, and you can feel it anecdotally. Each new model version leap feels smaller, more incremental than the last. The magic is becoming harder to find. The simple foundational story of bigger is always better, just got a lot more complicated. The industry may have to learn that intelligence is not just about size, but about structure. In the relentless push for artificial general intelligence, a single academic paper can shift the entire landscape. This one, titled Emergent Analogical Reasoning in Transformers, did exactly that. It wasn't just another benchmark report. It was a deep, methodical investigation into one of the most human-like aspects of intelligence. The paper probed the cognitive leap we call analogy, the brain jump that maps the relationship from one pair of concepts to another. This isn't simple pattern matching. It's about understanding abstract structure and transferring it to a new domain. The researchers wanted to know, can large language models truly reason this way, and what conditions are necessary to unlock this skill? To find out, they went back to basics. They trained a suite of transformer models entirely from scratch, meticulously controlling for size. They focused on a key architectural parameter: model width, scaling it progressively from a narrow 64 dimensions up to 512. This allowed them to isolate the effect of width on the model's ability to form analogies. This was a rigorously controlled experiment. They systematically tweaked the training data, the number of training steps, and the model's depth, all under strict scientific controls. Every variable was held constant except for the one being tested, ensuring that any observed changes in performance could be confidently attributed to the architectural scaling. The result was completely unexpected, defying the industry's core assumption. The smallest models failed to grasp the concept at all. The medium-sized models spiked, showing a remarkable aptitude for analogical reasoning. But then, the largest models, the ones everyone expected to be the smartest, actually performed worse. Their performance dipped. The paper's conclusion was a bombshell, stating plainly, quote, "Increasing model size does not monotonically improve performance on analogical reasoning." This finding directly challenged the prevailing bigger is better philosophy that had dominated AI development for years. The implication was clear. Simply throwing more compute at the problem isn't a silver bullet. More parameters and more data don't automatically lead to more sophisticated reasoning. In fact, for certain crucial abilities, it might even be counterproductive. The link between a model's size and its intelligence is far more delicate than we thought. It suggests that true reasoning isn't just about capacity, but about a specific kind of internal organization, a geometric alignment that can be lost if a model becomes too large and complex without the right guidance. That once smooth progress line, the one that pointed ever upward with every increase in scale, now has a dip, a valley. This inverse scaling phenomenon represents a critical new puzzle for the entire field. The myth of automatic gains from scale is cracking. The era of brute force scaling as the only path forward is facing its first major intellectual challenge. We can no longer assume that tomorrow's bigger model will naturally be a better reasoner. It's time to relearn how we build intelligence. The focus must shift from sheer size to sophisticated architecture and training methodology. It's a call for craftsmanship over brute force, for a more nuanced understanding of how these digital minds actually work. Understanding the why behind this dip, that is now the key. It's not a failure, but a signpost, pointing us toward a new frontier in the quest for true artificial intelligence. The answer is geometric alignment. The model needs a tidy inner map of concepts, like a city map, two routes matching in distance and direction. In embeddings, king to queen should mirror man to woman. If that geometry forms, analogies click, but size alone can't force that map to emerge. It depends on data, design, and training settings. Sometimes models learn it, then lose it mid-training. So bigger clusters don't guarantee better reasoning. That should make AI leaders uneasy. Conclusion: size gives potential, not the blueprint. The craft is in making alignment happen, on purpose. They checked Google's Gemma, 2B versus 9B. They checked Meta's Llama family too. Same pattern. Bigger wasn't reliably better at analogies. What mattered? Did the right geometry appear? A smaller, aligned model could beat a larger, misaligned one. Ilya Sutskever said scaling's golden age is over. A new paper challenges old data rules. DeepSeek showed smarts can beat brute force. OpenAI is leaning into inference-time thinking. Google pushes Gemini reasoning. Anthropic moves the same way. Leaders like Jensen Huang, Sundar Pichai, Satya Nadella, and Sam Altman frame the next phase. xAI's Grok joins the race. GPT, Gemini, Grok, Claude, everyone's rethinking progress. Focus shifts to data quality, post-training, and how models think on the fly. Less brute force, more craftsmanship. The numbers are staggering. By 2026, big tech is projected to pour over $725 billion into AI infrastructure. This isn't just an investment, it's a colossal industry-defining bet, staked on a single powerful assumption. That entire bankroll is predicated on the idea that the next generation of models will become exponentially smarter, more capable, and more reliable simply by making them bigger. It's a belief that has fueled the market for years, that intelligence is a direct, predictable output of compute and data. But as this new research suggests, the core driver of true reasoning might not be raw capacity at all. The real breakthrough lies in geometric alignment, the elegant internal structure that enables analogy. And here's the trillion-dollar problem. Achieving that alignment feels less like engineering and more like a roll of the dice. It's an emergent property, a fragile state that can materialize unpredictably during a training run. If the limits of brute force scaling are real, and this structural alignment proves elusive, the entire investment thesis will be called into question. Markets built on the promise of infinite growth will have to confront a new, more complex reality. We may be discovering that the most human-like skills, analogy, abstraction, and common sense, don't scale linearly with budget. You can't just buy your way to understanding. This alignment can appear, flicker into existence, and then vanish within a single training process, leaving researchers with a model that's large, expensive, but fundamentally unintelligent. Imagine spending hundreds of millions of dollars on a single model only to miss the mark completely, to create a powerful pattern matcher that lacks the crucial spark of analogical thought. This changes the game. Winning is no longer about who can build the biggest digital brain. It's about who can skillfully guide the formation of its internal structure. And that insight opens the field to a whole new set of players. When the key isn't just capital, but cleverness, smaller, more agile teams can compete with giants. The age of easy scaling, of simply adding more servers and assuming better results, may be drawing to a close. But in its place, a more exciting era is dawning, one defined by true AI craftsmanship, where insight, technique, and a deep understanding of intelligence itself are the ultimate currency.